So here, finding the square of this and the cube of this might be helpful and easier than doing everything at once. I'm decided to do it. Just go bye. There's one. And we can substitute in those values in the equation. 5i 48 minus 4, this one is minus 6 plus 6 squared. And this one. So as we can see here, 48 minus 4 minus 6 minus 18 is just 0. And all these imaginary numbers actually equal to 0, which means 0 equals 0 equals 0. And it's verified. It's true. So hence, okay. So you remember that the equation has only real parts in it. So the other root must, one of the other root must be the conjugate of this root shown here. So which means the root 2 is actually just minus 1 minus I. So here we have two possible ways to solve this problem. The first one, we can make the equation is first we have to write the equation as little bit differently. You can divide every part by a half. Therefore, we can write the multiples of the root. So which means second root first root, and the other root we don't know. It you can just say it's a. And since the all x's yield up to this x3, we can just say all the products of the root is equal to -9. So we have this equation shown here. And if you multiply this equation, it gives 1, it's actually just 6, positive 6. A equals 9, which is just 9, 3/2. Okay. Question number 8. The coordinates of x, y of a general point of curve satisfy the differential equation shown here. It's given that y equals 1 when x equals 1. So the differential equation obtaining an expression for y in terms of x. So to solve the differential equation, we have to take integrals from both sides. But to do that, we have to collect the terms, and one side only has the y's with dy dx, and the other side have just only the x's. So if we rearrange this formula, dividing by y to get y here and dividing by x to x here, we have this equation. And we can take integral from both sides. This dx is cancel each other, so the equation becomes just so we can just write that as shown here. Okay, so the left hand side, in other words, this one, is just equal to L and absolute value of y plus c. And the right hand side, 1 over x is 2x dx, and is equal to L and absolute value of x, and minus x squared plus c. And if we combine the two sides, we get this miraculous equation. In here, if we substitute values x equals 1 and x equals y equals 1, we'll get this. Since L and 1 is just 0 and this is 0, the c value is just 1 in this case. And to get expression for y, we can exponentiate the both sides. So it's gonna look like this. And it gives our final answer here. Okay, the question number 9 asks express f of x in partial fractions. To get partial fractions, first we have to decide the final form of partial fractions. Okay. If you multiply both sides by this equation here, this gives us the equation here to solve. So here we can substitute different values of x to get the values of a, b, and c. So I'm gonna choose first the x equals 1. So choosing 1 actually eliminates these two terms. So we have the equation to solve for only a. When you assume x equals 1, the left hand side becomes just 25 and this side becomes just 25a, which means a is equal to just 1. In the second case, I'm gonna choose let x equals minus 2 or 3. So it gives us the left hand side is just 10, and in here, in this time where seems this side is 0 and this side is 0, so we can find c. In this case, c is just this one, which means c is equal to 6. So to find b, we can equate the coefficients of x squared and on the right hand side we have 12 as coefficient of x squared. The right hand side it's 9a and minus 3b. And we already know that a equals 1. So it's just this one, which means b is equal to minus 1. So the final form is gonna be 1 over x is 1. Okay. And the next part, hence, obtain the expansion of f of x in ascending powers of x up to and including the term x squared. So here we can find the terms ascending powers of x squared using binomial method. So from the last part, our equation became this. So to solve this, we can divide our equation into three parts, part 1, part 2, part 3. Let's solve the part 1 first. Let me rewrite the equation as this one. We can approximate this as in the binomial expansion to get this. This one, sorry, it's minus x. 1 minus 1 minus 1 minus 1 is x squared 2 factorial and dot. And this means it's just 1 plus x plus x squared and dot. To get the second part to approximate, let's first like this one. To approximate our integer here must be 1. However, in this case, that integer is 2. So we can use this formula from ASL book, which states that If the form was this, we can write this as here. So using the formula, this equation comes this one, and we approximate. Which gives this one. When you simplify them, and when you further simplify this, it's just 102 minus, and this one. For the third part, we can also use that same formula before. Which gives us approximation almost this. So we are approximated the three parts as this, and now we can just add them together to get our answer. So our answer is gonna be 1 plus x plus x squared half this. So you may ask what happened to this minus. I already multiplied minus those here to get here results here. I multiplied these results by -1 to get the results here. So don't worry about that. Which actually gives just 2 minus 11 over 4 and this one. And here is our answer. Okay, the question number 10. The diagram shows curve, function that, and its minimum point m. Find the exact coordinate of m. So in here we can differentiate this function. You can set it derivative to 0 and can have the x coordinates of m, and then using that x coordinate to get y value. So to differentiate this function, it's actually a composite function. So I'm gonna make them u and v. So the u part is 2 minus x, and v part is this one. When we take the differentiation, find derivative, use these values. And if we get the derivative, it gives this. Sorry. Here, and we can set it to 0. And since we have this and this is similar, we can make a bracket of it. -1. And since we're multiplying it by 2, it's just -1 and another -1 and 0. Sorry. Since this part never reaches 0, we can assume this part only gets to 0. It's this one. And if we solve for x, it's just x equals 4. And to find value of 4, we can substitute x equals 4 to original equation. Get this one, which actually just is. And the coordinates of m is this. And the second part asks, find the area of the shaded region bounded by the curves and the axis, and give your answers in terms of E. So let's see the curve, and here, let's just, we have to find the value here. Which means we have to first find the intersection here, to do definite integration. So let's set this to 0, which just gives x equals 2. Only this part can have the answer. This part is no, it can't have the value x to something to get 0. And now I can just integrate the function to get our answer. So to integrate this function, we have to do integral by parts. So I'm gonna choose u as 2 minus x, which gives just only -1. dv dx is here, and this one. So the integrals gonna become and the rule of power integration by powers shows this one between 2 and 0. So this x's cancels each other, and actually this function is seems so like this one. So final form will look like this. Now, when you substitute values, to boom, blah, 0, 0, and 0 here. Which gives this one. That's one, this one. 4. Which is just 4e minus 1. Oh, sorry, it's plus. Okay. So here's question number 11. And two equations have two lines of equations shown as one, where a is just constant. Given that two lines intersect, find the value of a and position vector of the intersection. So here I'm gonna write out the line equation in a very simple form. So in this case, I'm gonna just add these one to each other to get this. What is here? Since the question says these two intersect, these values, this one, this one, this one, this one, and this one, is actually uh, equal to each other at the intersection. So we can have three simultaneous equation from this just one, just two line equations. So the first equation is gonna be this one. First, we don't know the alpha value from this equation, a value from this equation. So we have to find lambda and mu from bottom two equations. We rearrange them. We have this and this. So the equation will become this one. Which means it's lambda c minus 3, and if we substitute that value there, well, mu equal to 5. So in the next step, we can find A since we have found lambda and mu, which means alpha times 3 plus 1 equals 2 plus 2 times 5. Which is 11, and A is just minus 11, 3. From here we can calculate the position vector of intersection. Since we have known the A value, we can just use this expression to find the alpha value, the intersection, which means I plus 2j plus k and which means it's just this. Good. The last part, given instead the acute angle between the direction of two lines is cosine minus 1 is just 1/6. Find the two possible values of A. So in this case, we have to use formula this A and B for dot product and cosine theta. If you rearrange this formula, the theta is cos 1. So this means just this one is equal to 1/6. So first, let's find out the dot product of A and B. So the dot product of A and B is this, which is 2A minus 2 minus 1, which is 2A minus 3. And length of A is a squared plus 2 squared plus minus 1 squared. Here's this equation for the B. 2 minus 1 squared 1, this squared, which is just square root 6. Which gives us the final equation for our solution, this one. And if you cross multiply the equations, we get this. Looks like this. If we take 6 and combine two square roots, we get this. And when you square the both sides, it's just this one. Yay. Now it's actually just this. If we collect the terms, it's just this. And now you can just solve it as a quadratic equation. And if you solve it as that, it's just a equals 1, and the other one is a equals 49/23.